Welcome back guys. In today's video I'm going to be going over the Kaspa coin GhostDAG protocol and explaining to you guys how it works and how it differs from the normal blockchain used by most cryptocurrencies today. But before we get into the video, I want to thank our sponsor today, and that's CryptoPool Online for Kaspa coin mining. So right now to the end of January, CryptoPool Online has allowed for zero pool fees when mining. This helps us miners that have high power prices right now. The pool offers both solo and pool mining for Kaspa. At the top here you can select what type of mining you want to do, and then I'll run through the setup of Kaspa coin mining. First you need a wallet address, and then you can download any of these miners listed below. They then offer pre-made command lines here, and all you have to do is change the wallet address as you can see here. Right now they are working with the Kaspa coin team on the new rewrite of the coin. After this has happened, they have told me that they plan to expand to global servers and possibly venture into other coins in the future. So head over to CryptoPool Online right now and start mining Kaspa. The link for that is in the description below. So here we have the Phantom GhostDAG paper, which was written back in November of 2021, which is very new in terms of crypto scene and is why Kaspa coin has had its massive rise in the last year. It's implementing some cutting edge technology in the space right now. It's written by 3 people, and I believe the first 2 people are founding developers of Kaspa coin, and the third person also helped with some development along the way. Now it says at the top that the GhostDAG is a scalable version of the Nakamoto census by Satoshi Nakamoto. So I've gone through this and highlighted the main points that explain how GhostDAG and Phantom works. A lot of it is about equations, which many people might not understand, so I'm trying to break it down so it can be understood by anyone new to the space. So let's start off by going over the abstract and introduction. Here it says in the paper, we present Phantom, a proof-of-work based protocol for a permissionless ledger which generalizes the Nakamoto blockchain to a direct acyclic graph of blocks. For those who are wondering, that's what DAG stands for, Directed Acyclic Graph. Phantom includes a parameter k that controls the level of tolerance of a protocol to blocks that were created concurrently, which can be set to accommodate higher throughput rate. It thus avoids the security scalability trade-off which Satoshi's protocol suffers from. Phantom solves an optimization problem over the BlockDAG to distinguish between blocks mined properly by honest nodes and those created by non-cooperating nodes who choose to deviate from the mining protocol. Using this distinction, Phantom provides a robust total order on the BlockDAG in a way that is eventually agreed upon by all honest nodes. Implementing Phantom requires solving an NP hard problem. And to avoid this prohibitive computation, we devised an efficient greedy algorithm called GhostDAG that captures the essence of Phantom. The GhostDAG protocol has been implemented as an underlying technology of the Kaspa coin cryptocurrency. So this paper is written about the consensus and not to be confused with the white paper of Kaspa coin. Next bit highlighted talks about Bitcoin and explains the throughput of the network for comparison. The security of the Bitcoin protocol relies on the blocks propagating quickly to all miners in the network. Block creation itself is slowed down via the requirement that each block contains a proof of work. In order to guarantee this properly, the creation of blocks in Bitcoin is regulated by the protocol to occur once every 10 minutes, and the block size itself is limited to allow for fast transmission. As a result, Bitcoin suffers from a highly restricted throughput on the order of 3 to 7 transactions per second. So we have known that Bitcoin suffers from this low transactions per second, so Kaspa coin and the GhostDAG is trying to increase the transactions per second without sacrificing security or decentralization. Now let's move on to the structure of the BlockDAG. So here we have this paragraph, and it says that using the structure of the BlockDAG, we can recognize a set of well-connected blocks. This procedure is used to exclude blocks created by misbehaving nodes and is the heart of the protocol. Blocks that either reference only old blocks from the DAG or are withheld by their creator for some time will be excluded from the set of blue blocks with high probability. I'll cover more about why they call them blue blocks later, but let's have an actual look at the BlockDAG structure. As you can see here, it's very different from a simple blockchain where one block comes after another. Instead, the BlockDAG has multiple blocks which are connected to others. These are referred to as parent and children blocks. To get a better understanding, we can head over to the Kaspa coin website and look at the Block Explorer. Here we have a real-time update in chain. Now if we click on one of these blocks, we can see it gives information on the block itself. Here we have the parent blocks listed here, which are the ones that came before this block, and then here we have the children blocks, which are the ones that came after. So each block will reference the blocks before and after. You can then trace all these references back to the first block in the chain. This is what secures the chain. Now that kind of gives you a basic explanation, but I want to dive deeper and show you how the network is secured to get rid of attacker blocks. So rather than extending a single chain, a miner in Phantom references all its new blocks and all the blocks, where G is the DAG that the miner observes locally at the time when the new block is created. Additionally, the miner should broadcast its new block as fast as possible. These two rules put together constitute a DAG mining protocol in Phantom. The aforementioned DAG mining protocol implies in particular that even when two blocks containing conflicting transactions, both blocks are incorporated into the BlockDAG and referenced by all honest miners. The core challenge then is how to recover the consistency of the BlockDAG. This is done in our framework by ordering all blocks and by extension all transactions and accepting them transactions one by one, eliminating individual transactions that are inconsistent with those approved before them. So the chain constantly looks back and verifies transactions individually as they come up. The next part is the rules which keep the network secure. The ordering rule of Phantom has two stages. First, we divide the blocks into blues and reds. The blues represent blocks that appear to have been mined by cooperating nodes, so honest nodes, whereas blocks in red are set as outliers that were most likely mined by malicious or strategic nodes. Then we order the DAG in a way that favors the blue blocks and penalizes the red ones. Just like Bitcoin, Phantom relies on the ability of honest nodes to communicate their peer blocks' recent blocks in a timely manner, and on the assumption that the honest nodes possesses more than 50% of the hash rate. This is just talking about 51% attack on the network, so as long as you have more than 50% of the nodes that are honest, then the network can be secure. In the GhostDAG, the protocol selects a K cluster, which induces a coloring of blocks as blue and reds. However, instead of searching for the largest K cluster, GhostDAG finds a cluster using a greedy algorithm. The algorithm constructs the blue set of DAG by first inheriting the blue set with the largest blue set in its past. So it constantly looks back and looks for the blue set, and then it adds to this next blue set. We can see an example of this below, where we have reds and blue blocks. The reds will be discarded and the blues will be the main chain that's kept. They call this a greedy algorithm, and it says here that the example shows the largest 3 cluster of blocks within a given DAG are colored in blue. It is easy to verify that each of these blue blocks has almost 3 blue blocks in its anticones, and that this is the largest set with this property. So for those wondering, anticones are like a clutter in this sense, so they have more blocks connected to it, so that a typical anticone size should not exceed 3. Blocks outside the largest 3 cluster belong to the attacked in red. For instance, block E has 6 blue blocks in its cluster, but these blocks didn't reference E, presumably because it was withheld from the miners. So because the E block isn't included in any of these other block references, therefore it can't be traced back. So if the blocks does not reference the previous blocks in the main cluster, then it's assumed to be an attacker. Below this, we see another example of the steps the network takes to create the chain. The network basically looks for the most connections between blocks. The more connections backwards, the more reliable the block is. So this is why it's called a greedy algorithm, because it favors the blocks with the most connections and that can be connected back to other blocks. Now I want to move on to the scalability of this protocol. On the main result, it says that a protocol is scalable if it's safe to increase the block creation rate without compromising security. That is, if security threshold does not deteriorate as block creation increases. They then claim that GhostDAG is a scalable protocol, and then they prove this through these equations below. And then I've highlighted how Kaspa allows for 1 second block times here. The value of block creation should be set to such that nodes are expected to participate in a system that can support such a throughput. For example, if nodes are required to maintain a bandwidth of at least 1 megabyte per second, and blocks are the size of 1 megabyte, then the block creation rate should be set to 1 block per second. This is one of the best things for solo miners and for network speed. So in theory, they might be able to increase to a bandwidth of 2 megabytes to allow for 2 blocks per second. They then below talk about how they could improve transactions per second within the blocks. They say this can be done by increasing block rate, as we said earlier, or increasing block size. They then explain how this can be done either through sharding or by incentivizing randomization in miners to avoid collisions on the network transactions. Therefore, they will maximize more profits if they comply with the network. Both of these can be used in GhostDAG to increase the throughput of the network. Now the last bit I've highlighted is the implementation of GhostDAG into Kaspa Coin, and it covers how Kaspa Coin has proved that the GhostDAG can work in a real-world implementation. Here it says, unlike simple proof-of-concept simulations, the Kaspa Coin network provides evidence of the feasibility of GhostDAG in real-world situations where the global hash rate fluctuates. The network miners are organically spread, nodes are required to synchronize and verify blocks reasonably fast, and the network has been running for extended periods of time. At its current state, the fully operational network easily handles a throughput of 40 transactions per second, where the average waiting time for a single confirmation is in the order of seconds. We stress that the throughput of 40 transactions per second is larger than the highest throughput ever witnessed on both Ethereum and the Bitcoin networks, whose confirmation times are longer by orders of magnitude. We tested the confirmation times of the network by generating a total of 458,000 transactions and measuring how long before each transaction got the first confirmation. So they have here a graph of over 400,000 transactions on the network and their time in seconds to be confirmed. As we can see, there are some outliers, but a majority of them are confirmed within 10 seconds. Only 30% of the transactions are confirmed over 10 seconds, and it gets lower as time goes on, obviously. However, this is still extremely fast confirmation times. Bitcoin has many confirmation times upwards of an hour. The only problem that Kaspa Coin has is it doesn't have enough transactions on the network to be able to prove the higher transactions per second. It said in its paper it's already proved 40 transactions per second, but this paper was written over a year ago. Recently, Kaspa has decided to rewrite their coding language into Rust to allow for more transactions per second on the network. It says here that they have a goal of 32 blocks per second, which is way higher than the 1 block per second right now. They even said that 100 blocks per second could be reasonable in the future. If they could achieve this, it would allow for anywhere between 6,400 to around 20,000 transactions per second, thus being that the only limiting factor would be the internet connection of the network. Now, this is one of the main things that crypto needs to be used as a currency, and this is higher transactions per second. Central banks can process up to around 250,000 transactions per second on their systems and could push that a little bit higher. So for a cryptocurrency to compete with these bank transactions, they need to have a higher throughput rate. So hopefully Kaspa can see a way to scale this up further past 20,000 transactions per second, but as I said, it's yet to be proven, as there isn't enough transactions to even prove the concept yet. All these equations prove it, but until we see it in real time, we won't have any idea how the network will react. Kaspa Coin has been very successful so far in the crypto space, even in the short time it's been in the mainnet phase. Currently, it sits around 250th place on the list of cryptocurrencies by market cap. I think the implementation of GhostDAG has allowed for this massive price increase. Everyone in the mining space is mining it because of its high profits, and I've even made loads of videos on the coin myself because its technology is relatively new and a fresh take in the crypto space. Now, there might have been some things that I missed in the GhostDAG paper which were important, but I wanted to explain more how the network works on a basic level. So if there's anything that I've missed that you want more information on, then leave a comment below and I'll try my best to give you an answer. Lastly, like the video and subscribe for more content like this.